Let's look at Chief Mate's SQA November 2013 question number 3 for stability. It says a vessel is floating upright in salt water and is about to dry dock. The vessel's particulars are kg 8.47 meters. Present draft forward is 5.010 meters and aft is 6.690 meters. Part A of the question says, using the hydrostatic particulars contained in the stability data booklet, calculate the vessel's effective GM at the critical instant. Part B says, describe methods of improving the initial stability if the GM at critical instant is found to be inadequate. In order to proceed with the question first, we need to find out the arithmetic mean draft. So arithmetic mean draft is found by forward draft plus aft draft divided by 2, which is equals to 5.010 plus 6.690 divided by 2. The arithmetic mean draft we got is 5.850 meters. Now we'll find the LCF at 5.850 meters. LCF at 5.850 meters was found out to be 68.500 meters. This was obtained from the hydrostatic data by doing the interpolation. True mean draft is equals to aft draft minus trim times LCF over LBP. We know the aft draft of the vessel is 6.690 meters. The trim of the vessel, which is the difference between forward and aft draft, is 1.68 meters. And the LCF of the vessel is 68.500 meters, which we have obtained and has come from here. The length between perpendicular for the vessel is 137.5 meters, which has been obtained from stability booklet. While solving this equation, we get true mean draft is equals to 5.853 meters. Now we will find out various values with respect to true mean draft, which is now 5.853 meters. We look into hydrostatic data, and by doing interpolation, we found out the displacement of the vessel in salt water is 11967.4 tons. The MCTC in salt water is 167.9. The LCF of the vessel at 5.853 meters was found out to be 68.496. We'll first calculate the P force which is acting on the vessel at the time of critical instant. So to calculate the P force at the time of critical instant, we have the formula which is equals to trim times MCTC over LCF. Now since MCTC has been used in the formula, the trim should be in centimeters. When we put in the values, we got trim equals to 168 centimeters. The MCTC was obtained as 167.9, which comes from here, and LCF was 68.496, which has come from here. We get an answer of 411.8 tons. This is equals to the P force, or we can say as the virtual loss of weight. Now we know that while the ship undergoes dry docking, if we look at the point of G and point of M, both these points tend to move. The M may move up or may even move down, but the G always moves up. In this case, we'll get G1 or M1, which will be our GM at critical instant. If we look at an instant somewhere here where M has actually moved up, we will name it as M2, and G, which we always know that always moves up, we will name it as G2. In this particular case, it is clearly observed that G2M2, which could have been the GM at critical instant, is actually more than the GM which was at the ship initially. So first we'll calculate the P force which we have done and found out the value as 411.8 tons. This will take into consideration the movement of M from its place, which can be increase or which can be decrease. Now, loss of GM, we know that when we draw the drawing, which is G and M, G always moves up. Uh, M is the one which may move up or may move down. So we'll calculate loss of GM by the formula P times kg over displacement minus P. When we put in the values, we have got P as 411.8 tons, which we got from here. The kg was given in the quotient, which is 8.47 meters. The displacement of the vessel we had interpolated initially and found out to be 11967.4 tons, and P of the vessel, which is 411.8, has come from here. When we solve this equation, we found out the loss of GM to be 0.302 meters. The next step is to find the effective displacement. So effective displacement is the displacement which includes the P force or the virtual loss of displacement. So the initial displacement was 11967.4 tons and the P force was 411.8 tons. So the effective displacement is 11555.6 tons. When we have calculated the effective displacement, the next thing we will do is to find out the Km at the effective displacement. The Km at effective displacement was found out to be 8.642 meters by doing the interpolation and looking into the hydrostatic data. The effective Km of the vessel takes into consideration the movement of M, which may be up or which may be down. So when we have applied effective Km, it has taken into consideration the movement of M. Now the only thing which is remaining is the movement of G, which we know that it always moves upwards. So after taking into consideration the movement of M, which we had done by finding out the effective Km, will now take into the consideration the movement of G. So we can say that critical GM is Km effective minus loss of GM minus kg of the vessel. So when we interpolate the when we input the values, the Km effective was 8.642 meters. Loss of GM, which was 0.302 meters, had come from this place, and kg of the vessel was given in the quotient, which was given as 8.47 meters. So critical GM was found out to be minus 0.130 meters. Here, this is the final answer as required by A.